Hi, I'm Tom Woods. I'm with the University of Colorado. We're in a research institution called Laboratory for Atmospheric and Space Physics. The NASA Solar Dynamic Observatory is a mission, first one for the Living with a Star program for NASA. It will be going to a geosynchronous orbit such that it will be able to study the sun real time, 24/7. Goals of the SDO mission is to study the magnetic fields of the sun and how it originates into solar activity and all the activities and storms that affect what we call space weather. The sun is a very violent star. A typical day you'll see a few small flares. Every couple days you'll see a fairly large flare, and associated with these flares the intensity can change by a factor of 2 in just a matter of minutes. In addition to that, it also can release particles, high energy particles that will be racing toward out away from the sun. Some of these will eventually hit Earth and affect our space weather. Extreme ultraviolet radiation is very dangerous to human safety if it could come to Earth. It, of course, luckily is absorbed in the Earth's atmosphere. The instrument that we have built here at LASP at University of Colorado is called the EVE instrument. It stands for EUV Variability Experiment. It's going to be measuring the extreme ultraviolet radiation from the sun and studying how it varies with time. I will be making measurements with EVE every 10 seconds, 24/7, every day, and that data will be transmitted down to the ground real time. We'll be able to look at these data every minute and be able to eventually forecasting of what the sun's doing. We're expecting a lot of new results out of our new SDO EVE instrument. One of the big impacts is understanding solar flares. We've been limited by amount of data. That is, we can see only about 3% of the flares with our previous instruments. We're going to be able to see 100% of all the flares, and these are several flares per day. So understanding flares and understanding how to forecast flares is going to be some huge discoveries in that. There's many good examples of solar activities that affected our technology and our communication and operations. There's one that many people may have heard of, the Halloween storm of 2003, where we had a large number of flares and a large number of coronal mass ejections, these particles that come from the sun, and they impacted our technology. For example, people did not have GPS as far south as Florida during this storm. People had to reroute their airplane flights over the poles because of radiation safety issues during that storm. And it's also an interesting time when you get to see aurora as far south as Mexico. LASP has a great tradition of working with students at all phases of our program, starting with helping to design the instruments, help calibrate and test the instruments, as well as help operate the instruments. And our primary focus, of course, is getting science results out of these instruments, so they help also with the data analysis. And LASP has had a long history of making solar measurements, starting back in the 1940s, even before NASA was formed, to study, at the time, the solar ultraviolet radiation and, of course, the effects on things like ozone. So this is going to be really making new discoveries in how the sun is varying at these short wavelengths.